All right, here we go with geometric sequences. This is section 11.3 in our book. Let's see. We talked yesterday about an arithmetic sequence, which is when you add the same thing to get to the next term. Geometric sequence is kind of the same thing, except in a geometric sequence, instead of adding, you multiply by the same thing each time. In other words, let's see, each term is a constant multiple of the previous term. It's also, you can also think of it as where the ratio of any two terms is always the same. So that's what a geometric series is. A few examples of geometric series, if you look at these. Number one here, if you look 1 to 2 to 4 to 8 to 16 to 32, each time I go from one term to the next, I'm always multiplying by 2. So this is a geometric series. And we call the ratio, the number that you're multiplying by to get to the next term, that's going to be called the common ratio. Just like in an arithmetic sequence, you had a common difference. In this case, it's the common ratio, and R is 2. If you look at the next one, 200 to 100 to 50 to 25, each time we go from one term to the next, we're taking half, or you have to think of it as multiplying. We're multiplying by 1/2. Sometimes it's going to be hard to look and just guess the ratio. The way you can get the ratio is just take any two consecutive terms, doesn't matter which ones you choose. In that case, I chose the 50 and the 25. And to get the ratio, you simply divide the second term that you chose by the first term. 25 divided by 50 does reduce to 1/2. So that's how you can get your common ratio. If you look at number 3, this one actually is not a geometric series or sequence. And the reason is if I took the ratio of my first two terms, the first two terms say the ratio is 18 over 12, which reduces to 3/2. But if I took, say, the last two terms, I looked at those are saying that the ratio is 36 over 27, which reduces to 4/3. And since those are not the same, that means that number 3 is not geometric. And that space isn't. So number 3 is not geometric because the ratio does not stay the same. Okay, right now the first 4 terms, if it is geometric, find the ratio. This is the exact same thing we've been doing. To write out the first 4 terms, you simply plug in 1, 2, 3, and 4 for n. I won't do number 3. But if I did number 2, I'm going to start by just plugging in 1. So 1/3 to the first. My next term is going to be 2 times 1/3 to the second. My next term is 2 times 1/3 to the 3rd. And 2 times 1/3 to the 4th. And if we clean that up, remember your order of operations when you multiply these. Do the exponents first, 1/2 to the first, 1/3 to the first, 1/3 to the second. Make sure you do that part first. 1/3 to the first is 1/3. 1/3 squared. 1 squared is 1. 3 squared is 9. 1/3 cubed. 1 cubed is 1. 3 cubed is 27. 1 to the 4th is 1. 3 to the 4th is 81. Now I'll go through and I'll multiply by 2 for each one of them. I'm kind of doing this in a weird order. And I'll bring down those 2's. 2 times 1/3 is 2/3. 2 times 1/9. 2 times 1/27. And 2 times 81, or 1 over 81. Then we need to find out if this is geometric. If I take any two consecutive terms, let's look at these first two. That says my ratio is going to be 2/9 divided by 2/3. And when you divide fractions, you flip and multiply. So 2/9 times 3/2. And let's see, we can cancel some stuff. 2's cancel. 3 goes into 9 3 times, and we're left with 1/3 for the ratio. And just to kill it dead, let's do the ratio with those last two terms. If I did 2/27 and 2 over 81, my ratio would be 2 over 81 divided by 2 over 27. Flip and multiply 2 over 81 times 27 over 2, and we'll cancel that. The 2's cancel. If you'll have your calculators, but 27 does go into 81 3 times, and that is also 1/3. And since I got the same ratio, this is a geometric series. Technically, I guess I would need to do the middle two also, but this one is geometric with the ratio of 1/3. If we look at number 2, and I find my first 4 terms, this one's going to be a little bit easier. If I plugged in 1, that's going to be 2 over 2. If I plugged in 2, 2 plus 1 is 3, so 2/3. 2/4, and 2/5. And if I found the ratio of these, we're going to get different numbers. If I looked at my first two terms, my ratio is 2/3 divided by 2/2, which is 1, and that would just be 2/3. But if I found my ratio for my last two terms, that's saying that my ratio is 2/5 divided by 2/4. Flip and multiply, 2/5 times 4/2, and that ends up being, after you cancel, the 2's cancel, that ends up being 4/5, which is not the same as 2/3, so this one is not geometric. So there we go. Let's see, finding the nth term of a geometric sequence. There was a formula for an arithmetic, there's a formula for geometric as well. One thing I would do is change the way that's written. It's going to be the same thing, but I usually think of it as a⁻1 times the ratio to the n power, or n-1 power. Just remember your order of operations. You do need to do the exponent before you do any multiplication. But it is ratio to the n-1. And I ask you to write the general term. The general term is you just plug in the first term and the ratio. So number one, I gave you the first term. So my nth term, my general term, is my first term, 3 times the ratio to the n-1. And that's all there is to that one, because I gave you what you needed. Now number 3 is going to be a little bit tougher because I didn't give you the first term. So all I can say right now is my nth term is my first term times the ratio. I do know the ratio, 4 to the n-1. And now to get my general term, I'm actually going to have to solve for my first term, and I'm going to use the fact that when n is 3, my third term is 16. So I'm going to plug in 3 for n, and that would give me a⁻1 times 4 to the 3 minus 1 needs to equal 16, because that's what my third term was, and we'll solve that equation. 3 minus 1 is 2, and 4 squared is 16, so that's saying a⁻1 times 16 is 16, and that means my first term is 1. And then once you get the first term and the ratio was given to you, then you can plug them into your formula. So my general term now is my first term times my ratio to the n-1, and that's our general term for number 3. And something I should have probably mentioned before I got halfway into this. How much time have I spent? 7 minutes, not bad. Somebody asked in first period yesterday if y'all should be taking notes, and that's completely up to y'all. Just remember, we're flipping everything. So if you would normally have a sheet of paper out taking notes in class, then you probably should have a sheet of paper out taking notes right now. And one of the luxuries of this is you have the option of just pausing the video to try to catch up, or if I move too fast, just go back and pause it for a minute. And you can write down whatever it is you need to write down. I would definitely write down these formulas because we're going to be using these quite a bit this chapter. Let's see, looking at this, let's skip number 2, and we'll do numbers 1 and 3. Here I'm wanting the 7th term, and to get the 7th term, I'm going to need to find the general formula, which again is the first term times ratio to the n-1. I'm going to do exactly what we just did on those last problems. To get my general term, it's my first term, which in the case of number 1 is 2, times my ratio to the n-1. And to find my 7th term, I'm simply going to plug in 7 for n. So my 7th term, it is 2 times 3 to the 7 minus 1. That's going to be 2 times 3 to the 6th power, and 3 to the 6th, I believe, 243. That's a guess. I'm probably about to embarrass myself. 3 to the 6 is, what the heck? 243. Is that like 3 to the 4th? I was 3 to the 4th. I was way off. Anyway, 3 to the 6th is 729. I was close. They both had numbers. And again, remember that when you're doing this, you need to follow the order of operations. Do the 3 to the 6th first. Do not do 2 times 3 first. You'll mess yourself up. Then finally, 2 times 729 is 1458. So that is my 7th term. I'm skipping over to number 3. Again, for my formula, I need my first term, and I can look at this and tell that my first term is 50. The ratio, though, is not explicitly given, but we're pretty smart. We can figure that out. I'll just take any two consecutive terms. And if I want the ratio, I'll do the second term, 12.5, divided by 50. And if you were to punch that in the calculator, you'll get 0.25 or 1/4. So there's my ratio. And if I want the seventh term, a sub 7 is my first term. I'm sorry, I'm getting my general term. A sub n is my first term, which is 50 times the ratio to the 7n minus 1 power. So there's my general formula. And now I'll get my seventh term by plugging in 7. So a sub 7 is 50 times 1/4 to the 7 minus 1. And I'll just plug that into the calculator. So I'll plug in 7, and let's see, I'm just going to plug that straight into the calculator. I had to go do something real quick. Now I've lost my train of thought. So 50 times 1/4 to the power of, and I know this advanced stuff, that's 6, 7 minus 1. And I'm punching that in the calculator, and it gave me an ugly decimal of 0.01220700313, some ugly stuff. What I'm actually going to do is get the fraction answer and see what that is, and it's 25 over 2048. So that is what the seventh term is in this sequence. That's a geometric sequence, finding the nth term. Let's see, moving on. Finding the sum of the first so many terms. This is the ugliest formula we're going to use this chapter, in my opinion. You do need the first term, you need the ratio, and you need the number of terms. So I'm going to look at this number 2 here. And to get my terms, I'm simply going to plug in and I'm going to write out maybe the first 2 terms here. So if I plug in 1, 2/3 to the first, 2 to the first is 2, 3 to the first is 3, plus, because we're doing the sigma, the sum of it. If I plug in 2, 2 to the second, 2 squared is 4, 3 squared is 9, plus, if I plugged in 3, 2 cubed is 8, 3 cubed is 27, plus dot, dot, dot. And I can look at that. The reason I like to write it out is because then the first term is staring you in the face. I know a sub 1 is 2/3. The number of terms, if I start at 1 and I go to 15, that's 15 terms. And then, let's see, so I have a sub 1, I have n, I need the ratio. And in a geometric series, if you remember, the general form is going to be r to some exponent. Now, this problem, it's not k minus 1, but the ratio is still 2/3. Whatever the number is being raised to the k or the n power is your ratio. And now that I have all of that, I can find the sum. And the sum of the first 15 terms is, it's my first term, which is 2/3, times, and you have to be really careful with this because it gets ugly, 1 minus the ratio, which is 2/3, to the n power, divided by 1 minus the ratio. And we're just going to punch this straight into the calculator. I'm going to pause it while I do that, but just punch this in the calculator and be really careful with your parentheses. Alright, so I punched that in, and I'm using the TI-84, which, if the fraction is too ugly, like if the denominator was just like something huge, it's not going to give you the fraction. It gave me the decimal 1.9954. If I was using my TI-89, it would have given me the exact fraction. My 84 right here is not going to do that. So we'll just say the sum is 1.9954. And then let's see, let's do number 3 over here. I've kind of run out of room. Let's draw, there we go. All right, so number 3, if I was going to do number 3, again, I'm going to write out the first couple of terms, because then I need to see my first term and my ratio, and if I write it out, it helps me do that. So that's going to be 2 times -1/2 to the 3rd power. Plus, remember, you are starting at 3. Pay attention to that. Plus 2 times -1/2 to the 4th power, and then we'll keep plugging in numbers and clean that up. If you cube a negative, it's going to remain negative, so that's going to be 2 times -1 cubed over 2 cubed. Plus, if I do a negative to an even power, it's going to become positive, so that's going to be 2 times positive 1 to the 4th over 2 to the 4th, which is 16. Let's see, 2 times -1/8, that actually reduces to -1/4, plus 2 times 1/16 is 1/8. And then it continues, and I can look at that, and I can tell that my first term is negative 1/4. My ratio, and again, the ratio is going to be whatever the number is being raised to the variable power. My ratio here is negative 1/2. And the number of terms, this is that counting principle I was telling you about. If I count from 3 to 9, I know the difference is 6, but there are actually 7 terms in that. So n is 7, and then we'll take that and we'll put that into the formula for the sum of the first 7 terms. It's your first term. I'm following this formula up here. My first term, which is negative 1/4, times 1 minus the ratio to the n power over 1 minus the ratio. And I'll pause this for a second and punch this in the calculator. And this one actually gave me the fraction answer. It's negative 43 over 256. So there's the sum of number 3. All right, the very last thing, and this one's going to mess with your minds. It's called finding the sum of an infinite geometric series. Now, infinite means the series never stops. It goes on forever and ever and ever and ever and ever. And it seems like that if you kept adding up things, if you went on towards infinity, it wouldn't add up to anything in particular. But if the ratio, if your common ratio is less than 1, then there actually is an infinite sum. And that's what we're going to use here. The good thing is the formula for an infinite sum is very nice and clean. It's simply your first term divided by 1 minus the ratio. So if you have an infinite sum, which like on number 3, I just told you to go on towards infinity, so it's pretty obvious this is an infinite sum. Number 2, it's not quite as obvious, but I did put ... there, meaning it just goes on and on and on. So to work these out, what we need is the first term, which in number 2 is 5, and the common ratio. And to get the common ratio, just take any 2 consecutive terms. I'll choose those 2 and divide them. Now remember, that is a negative 4/5 for my second term, so that's negative 4/5 divided by 5. And you flip and multiply, so that's the same thing as negative 4/5 times 1/5. And so my ratio is negative 4 over 25. And that is less than 1, so I can do this. So that means my sum is going to be my first term over 1 minus the ratio, which is negative 4/25. And we'll just punch that in the calculator. We'll do the same thing for number 3. I'm going to write out my first couple of terms just so I can see what a sub 1 is. If I plug in 1 for k, my first term starts with 1, so that's going to be 8 times 1/6 to the 1 minus 1. Plus, and then we'll keep going. But really, all I want to see is that first term. 1/6 to the 1 minus 1 is 0, and anything to the 0 is 1. So that's 8 times 1 plus some stuff, and my first term is just 8. So I can look at that now and say that a sub 1 is 8. And my common ratio, again, if you're looking at the general formula, whatever is being raised to the variable power, that thing is the common ratio. That is less than 1. And so I can find the sum, which would be 8 over 1 minus 1/6. I'm going to punch both those in the calculator real quick. All right, there we go. The answer to the first one was 125 over 29. This one, the sum was 48 over 5. So just punch those in. Take the quiz real quick. Shouldn't take you but a couple of minutes. And then I'll see you all tomorrow.